Hello and welcome. This is a robot localization demonstration. So I've got a camera pointing at the robot. You can see it in the bottom right hand window here. Robot is an EV3 Lego robot. So the challenge is the computer already has a map of the world. Now the challenge is, can it work out where it is on this map using only the information from the small colour sensor which it's got at the front? And that's all of the information that it's got. So let's just kick off the program and I'll talk us through it as it proceeds. So the large window that you see with the map of the world on, the green borders of countries with the sea indicates that's already programmed into it, already has that information. Now the brightness you are looking at, the whiteness, is indicating where it's a probability density indicating where it believes the robot is on the map at this current time. So it starts off, it doesn't know where it is to begin with. But you can see it slowly driving along. You can see it in the bottom right hand image down. And if you look at the main screen here where it says, and there's a list of information top, it starts with blue. So that's indicating the sensor's reading blue at the moment. So it can work out it's probably over the sea somewhere, not over the land. So the land is quite dark at the moment, but the sea is bright. It's particularly bright over the Pacific, indicating that it's a highish probability for being in that location. But as you can see, there's a reasonable level of brightness all over, so it could be in many locations. As it keeps driving along, as it's acquiring more information about where it has been, you can see that it knows that wherever it is, it must have been over a significant quantity of blue, which is why it's probably giving a slightly higher reading from the Pacific than it is for any other area. So we'll just let that drive along and we'll see what happens next. So it looks like it's just coming up to South America. If you look on the main map, it seems to indicate a highest probability of somewhere around Mexico. But again, it doesn't really know. There are many places where it could be. It simply doesn't have the information at the moment to know really. Okay, now we've suddenly seen this is a major change that's just gone on here. Now, as it's moved over into South America, you can see it's hit a land border and it's now indicating white, which is information coming in from the sensor. So it knows it must have been at that point very close to a land border. So that eliminates, it can't be in the middle of the Pacific anymore, the Atlantic or the Indian Ocean. It's got to be, and it now knows it's been driving over land for a significant time. So it's got to be somewhere inside one of these continents. So let's just kind of let it continue on and we'll see what it does next. Okay, now it's driving out into the southern Atlantic Ocean. So it's indicating blue here. And here we go. You'll notice that there's an element of symmetry. If you look at that South America area in particular, and what's going on is that from the robot's perspective, it knows it's been over blue, then it knows it's over land, and then it knows it's over the sea again. But it's quite hard to know which direction you were travelling at this point. It doesn't have enough information at this point to resolve which direction were you travelling in. Now, hopefully, when it makes landfall with southern Africa, that will introduce an asymmetry into the information that it has, and it will realise it couldn't possibly have been going from the east to the west. It must be going west to east, and it knows that because it will know that it hasn't hit any land there's no land in the sort of southern Pacific Ocean. So it knows it should be able to resolve at this point which direction it's going in. We'll see if that works or not. Let's see, it's got this sort of big arc, as you can see, saying it's not quite sure exactly where it is, but the robot in reality does lie within one of those bright spots, and it's doing reasonably well. And it should be able to eliminate certain things when it hits that land border. It's going to know. It's going to receive more information about where it actually is. Let's see what happens when it does that. So, where are we? Just coming out to southern Africa. Excellent. Yes. So it now has a high probability for being in some sort of strip lying somewhere between sort of mid-central Africa down to the south. Just to talk us through the meaning of that list just above the map, it says white. White is the information coming in from the colour sensor. 268 is just a countdown for the number of times it's going to do this drive cycle. It's programmed to stop it when it reaches 0. -1 is just a legacy number. Interesting. The 0.59, that's more interesting. What it's doing is it looks for the most probable spot on the map, and then it looks within a small vicinity of that and asks, what is the total probability that I am within a given vicinity? I think it's 10 pixels from what I remember. So within a 10 pixel box, rectangle region around that brightest spot. The reason for that is if you ask what is the probability of being exactly at a given spot, I mean, it's going to be very low. It's not a particularly meaningful piece of information, but the vicinity probably is. So that's what it's indicating there. So it's indicating it's a 53% chance that it's got that correct. Just from prior experience, usually when it goes above 90%, it's usually nailed it, and it usually is correct. But we don't have quite that level of confidence at the current moment. But I can see from the 2 brightest spots on the map, and you can see in the window there, that it has got roughly the correct position. This is built on a hidden Markov model, where the location and direction is the hidden state, which we need to infer. The observations are obviously the observations that come from the colour sensor. The observation matrix that indicates the probability of a particular observation given a location, that is using the pre-programmed map, the world map that it has. So it knows, for example, if the location was over land, you should expect to see yellow or white. Actually, their colour sensor gets a bit confused between white and yellow, so I have programmed it to treat them equally. So that's what the observation matrix is, and we're just trying to infer the location based on that information. The hidden states are discretized into, I think it's a 192 by 300 and I have given it 12 different possible directions, which sometimes might account for the sort of slightly separated blobs, which might be an artifact of the angle quantization. Anyway, so it now thinks it's somewhere over southern the ocean south of Australia, which it is indeed coming up to. Just see through there, it looks like it's coming up to Tasmania. And in reality, the robot's a bit before Tasmania, and obviously it's indicating it's slightly ahead of Tasmania there. Oh, it looks like it's nailed it. It looks like it has just bumped into Tasmania or southeastern Australia. It's not quite sure, but it has localized it down quite significantly. So I can see where I am that it's heading towards New Zealand now, which it is. This program is written in Mathematica, and we are communicating with the robot over a Bluetooth connection, which can be used to control the wheels and read information from the sensors, including the colour sensor. It's pre-programmed to stop when it hits red, so that's the reason why I've got a big red border around my map. That's to stop it just driving off tables and crashing. Okay, so it looks like it's leaving New Zealand, and it's just about to hit the map, and we will hopefully see it stop fairly soon. Oh, it seems it has got a little confused just at the last minute there, possibly, and it has stopped. Okay, and it has decided the final most likely position for it now is just exactly where it is, actually, just off New Zealand. Well, I hope you've enjoyed that demonstration. Thank you for watching.